everyone. Today we're going to continue our geometric problem solving part 5. We are now in number 34 problem. Find the angle x and the angle y. So to answer this question, we're going to analyze the given circle, the given intercepted arc, and the given central angle. So the question now asking for the central angle x and the inscribed angle y. First, we're going to compute for the central angle. So our central angle is angle x equals 180 degrees minus 135 because the given is 135 degrees and the semicircle here is equivalent to 180 degrees. That's why we need to minus 135 and the difference is 45 degrees. So that's only for the arc. And remember, if the intercepted arc is 45 degrees, so therefore this will be equal to the central angle, which is x. So that's why our angle x is equals to the intercepted arc 45 degrees. Next, we're going to find the angle y. The angle y is inscribed angle, and we have the intercepted arc is 45 degrees. We have to do is multiply by 1/2, so it's equivalent to 45 degrees divided by 2 now equals the half of 45 degrees is equals to 22.5 degrees. If this is 45 degrees, the half of the intercepted arc is equivalent to inscribed angle. So angle y equals 22.5 degrees. Next problem, find angle x. So this is the given circle. So based on the given figure, we have here the 90 degrees. This is the radius of the circle. And the measurement of this angle is, once there is a box here, this will be equivalent to 90 degrees. And as a matter of fact, the given is the intercepted arc 90 degrees. And our theory, the central angle here is equal to the intercepted arc. Since the intercepted arc is given is 90 degrees, equal to the central angle, so therefore our angle x is also 90 degrees. Okay, next number is 36. Find intercepted arc y and the angle x. So first we have to analyze the given circle, and we have here the diameter. So divided the circle into semicircle. So we have 180 degrees here, and the given angle here, which is the central angle, is 80 degrees. Remember our theory is that central angle is equals to the intercepted arc. Since we have central angle 80 degrees, so therefore this arc here is also 80 degrees. This is our computation. Central angle equals 180 degrees. It's also the same with the intercepted arc 80 degrees. Next, we are going to find this angle x. So angle x here, this is semicircle. Since we know the value of y is 80 degrees, so semicircle is 180 degrees minus 80 degrees, so we have 100 degrees, our answer for angle x. So our computation is 180 degrees minus 80 degrees. From here, central angle is equals to 100 degrees. Next, number 37, find angle y. So given circle, then there is a segment intersecting each other and form now an angle here. This angle is called the vertical angles. Remember in the theory, vertical angles are congruent. So therefore, if this is 140 degrees, so the angle y is also 140 degrees. So therefore, the angle y is 140 degrees. Okay, next number 38. Find the arc K, arc L, arc M. To answer these questions, we are going to analyze the given figures, which is the circle and there is an inscribed triangle. So, and there is an indicators here that the three angles are the same. So once the three angles are the same, there is a theory that the interior angles of a triangle is equals to 180 degrees. So divided by 3, so therefore each of this angle, the measure is 60 degrees. Then since the angle here inscribed and the circle, this is 60, then remember the angle here is twice the measure of the arc. So that's why the arc of K is equals to 60 times 2, 120 degrees. So this arc now is 120 degrees. Next, arc L here, the angle here is 60 degrees. The arc L is also times 2. So 60 times 2 equals 120 degrees. So the arc here, the measurement is also 120 degrees. And the arc M, the measure of this inscribed angle is 60 times 2 equals 120 degrees. Next, 39, find arc BF, arc DC, and arc FBC. So we have to do, to answer these questions, we have to analyze the given figures. The circle and the arc here, B to Z, 240 degrees, and this angle here, inscribed is 30 degrees, and the inscribed is 40 degrees. To find the arc BF, this one, so we have to do, remember, and one circle is 360 minus the sum of 240, the arc, the 40 here, and also the sum of CD. We have to do, find first the arc CD, 30 times 2, because this is inscribed, the intersected arc is times 2, so that's why here is 60. To get the arc BF, so we're going to add 240 plus 60 plus 40, we have 340, and 360 minus 340 degrees equals 20 degrees. So this is the 20 degrees, the arc of BF. And the CD done already, times 2 of 30 degrees equals 60. And the angle FBC, this angle FBC, we do not know this angle, so we are going to divide the given arc. Here is 40 to get the inscribed angle, so we're going to divide it by 2. 40 divided by 2 equals 20. So therefore, the angle FBC is equals to 30 plus 20 equals 50 degrees. Next, number 40 problem, find arc Y and angle X. So to answer these questions, of course, we're going to analyze the given circle and the tangent and also the secant. So from here, just going here, we have 250 degrees. Then, so our basis is 260 degrees. 360 degrees minus 250. So this arc now is 110 degrees. To find the angle X, our computation is that 110 degrees, which is the arc, times 1/2. So it becomes 110 degrees times 1 divided by 2. So the angle X is equals to 50 degrees. Next, number 41, find the X. So we have to study again the given circle, the given tangent, segment bisecting the angles here, and the given is 30 degrees and the missing is X angle. But there is a specific here, the meaning of this box is meaning 90 degrees. So this is now a complementary angles, these two. So we have to do, to solve the complementary angles, we're going to use 90 degrees minus 30 degrees is equals to 60 degrees. So therefore, the measurement of this angle is 60 degrees. Next, number 42 problem. Find the area of the shaded region. To answer this question, we are going to study or analyze the given figure. We have a semicircle and the shaded regions here, and we have two small circle here, semicircle. So our first step to compute is to find the area of the big semicircle. So the area of big semicircle is equals to pi r squared divided by 2. This is the formula. Then we have phi and the value of the radius. If this is the diameter, so the half of the diameter is 4. Because we have here 4, so the diameter is 8, the half of that is 4. So our radius is 4, then the squared divided by 2. We have 4 times 4, we're going to extract the exponent, becomes 16, and divided by 2. No need to multiply 4 times 2, that's wrong. So the result is 8 times 5. Next, we're going to compute the area of the small circle. The first one is here. This is the diameter of the small circle. So to get the radius, we're going to divide by 2. That's why our radius here is 2, multiplied by the 5, then squared, divided by 2. Then 2 times 2 equals 4, divided by 2. So the result is 2, 5. The second area of semicircle, we have the same formula that we're going to use, pi r squared divided by 2. Pi times the radius is the same, the half of 4 is 2. Then divided by 2. Then extract the exponent. 2 times 2 equals 4. Divided by 2 equals 2, 5. The final answer, the area of the shaded region is equals to the area of the big circle, or the semicircle rather. We have 8 pi, the result. Then minus the sum of the two small semicircle. We have 2 plus 2 equals 4 pi. Then we're going to minus 8 minus 4 equals 4 pi squared units. So the measurement of the shaded area here is equals to 4 pi squared unit.